Ecosystem services are the many benefits that people obtain from nature. These services are produced by the interactions between ecosystems, like forests, rivers, and oceans, and human societies. Since the early 2000s, especially after the Millennium Ecosystem Assessment, governments and organizations have recognized the importance of these services for human well-being and have started to include them in policy targets. Ecosystem services are essential for our daily lives, providing us with food, clean water, climate regulation, and even cultural and recreational benefits. Understanding what ecosystem services are is the first step toward making better decisions about how we use and protect our natural resources. Ecosystem services are not just a scientific concept, they are central to our survival and quality of life. They include everything from the crops we eat, the water we drink, to the clean air we breathe. These services also support our economies and cultures, influencing everything from job creation to spiritual fulfillment. When we make decisions about land use, agriculture, or urban development, understanding the trade-offs and synergies between different ecosystem services helps us achieve more sustainable and equitable outcomes. Without this knowledge, we risk making choices that could harm both people and the planet. Ecosystem services are generally divided into three main categories: provisioning, regulating, and cultural services. Provisioning services are the goods we can extract from nature, like food, water, and raw materials. Regulating services help control natural processes, such as climate regulation, flood control, and water purification. Cultural services are the non-material benefits we gain, including recreation, spiritual value, and a sense of identity. Each type of service plays a unique role in supporting human societies and maintaining the health of our planet. Visioning services are the tangible products we get directly from ecosystems. Think of the crops grown in fields, the fish caught from rivers and oceans, the wood harvested from forests, and even the water we use for drinking and irrigation. These goods are often traded in markets and have clear economic value. However, the supply of these resources depends on the health and management of the ecosystems that produce them. Overuse or mismanagement can lead to shortages and long-term damage. Regulating services are the benefits we receive from the natural processes that ecosystems perform. For example, forests and wetlands help regulate the climate by storing carbon and controlling greenhouse gas emissions. Vegetation and soils reduce the risk of floods by absorbing excess rainwater. Healthy soils maintain fertility for agriculture, and natural habitats filter pollutants from water. These services often go unnoticed until they are lost, but they are critical for maintaining a stable and healthy environment. Cultural ecosystem services are the non-material benefits that people gain from nature. These include recreational activities like hiking, birdwatching, and swimming, as well as spiritual and aesthetic experiences. Natural landscapes can inspire art, provide a sense of place, and strengthen cultural identity. While these benefits are harder to measure in economic terms, they are deeply valued by societies and contribute significantly to our well-being and happiness. Supporting services are the underlying processes that make all other ecosystem services possible. These include photosynthesis, nutrient cycling, and soil formation. While not directly used by people, these processes are essential for the production of food, clean water, and other benefits. Without healthy supporting services, the supply of provisioning, regulating, and cultural services would quickly decline. Biodiversity is at the heart of ecosystem services. The variety of species, genes, and ecosystems helps regulate the processes that provide us with food, clean water, and climate stability. Biodiversity also offers direct benefits, such as wild foods and medicinal plants, and supports cultural values. A rich diversity of life increases the resilience of ecosystems, allowing them to adapt to changes and continue providing services even under stress. Biodiversity influences ecosystem services in three main ways: as a regulator of ecosystem functions, as a direct source of goods, and as something valued for its own sake. For example, soil microorganisms help regulate soil fertility, while plants and animals provide food and medicine. Some species are appreciated simply for their existence, contributing to cultural identity and psychological well-being. Ecosystem services are not produced by nature alone. They result from the interactions between ecosystems and societies. The characteristics of an ecosystem, like species composition and tree cover, influence the type and amount of services available. At the same time, human management, technology, and access rights determine how these services are produced and who benefits from them. This interconnected system is known as a social ecological system. Fully understand and manage ecosystem services, we need to consider four key components: supply, delivery, contribution to well-being, and value. Supply refers to the potential of an ecosystem to generate a service. Delivery is how much of that service actually reaches people. Contribution to well-being measures the impact on people's lives, and value reflects the importance society places on the service. Each component requires different types of data and monitoring approaches. Supply is the potential of a social ecological system to generate a service, usually measured as a flow over time. For example, the amount of timber a forest can produce or the volume of water available in a river. Supply depends on ecosystem condition and management, and is often measured using remote sensing or ecological models. Delivery is about how much of the ecosystem service is actually extracted, used, or made available to people. For example, how much timber is harvested or how many people benefit from flood protection. Delivery depends on both the supply and on societal factors like access rights, laws, and infrastructure. Contribution to well-being measures how ecosystem services improve people's lives. This could be through better nutrition, increased security from natural disasters, or enhanced happiness and health. This component is complex and often difficult to measure, as well-being has many causes and is influenced by many factors beyond ecosystem services. Value refers to the importance society places on ecosystem services. This can be measured in monetary terms like the market value of timber or crops, or through non-monetary methods such as surveys and cultural assessments. Understanding value helps guide policy and management decisions, ensuring that the most important services are protected and enhanced. Components of ecosystem services are interconnected. The supply of a service enables its delivery, which then contributes to well-being and influences its value. In turn, the value society places on a service shapes how ecosystems are managed, which affects future supply. These feedback loops are crucial for adaptive management and sustainable use. Ecosystem services can be monitored at different spatial scales, from local to national and global. National statistics and remote sensing are useful for tracking progress toward policy targets at large scales, while field-based assessments provide detailed information at the local level. Combining data from multiple scales helps create a more complete picture of ecosystem service status and trends. National statistics, such as those collected by the Food and Agriculture Organization or the World Bank, provide valuable information on the production, trade, and value of ecosystem services like crops, livestock, and water. However, these statistics often miss informal activities and may not capture the full contribution of ecosystems, especially for non-market services or subsistence use. Remote sensing uses satellites, drones, and other technologies to collect data about ecosystems from a distance. This approach helps monitor large areas efficiently, providing information on land cover, vegetation health, water bodies, and more. Remote sensing is especially useful for tracking changes over time and for areas that are difficult to access on the ground. Field-based estimations involve collecting data directly from the environment, such as measuring river flow, soil fertility, or carbon sequestration. These methods provide detailed, site-specific information and help validate remote sensing and model results. However, they can be time-consuming and require specialized skills and resources. To make field-based assessments more accessible, toolkits like Tessa and Natura have been developed. These guides help local decision-makers and practitioners assess ecosystem services using standardized methods. They emphasize rapid, context-specific assessments and often include local knowledge and stakeholder input. Community monitoring involves local stakeholders in collecting and managing data on ecosystem services. This approach can be cost-effective, increase local engagement, and incorporate traditional knowledge. Community monitoring is especially valuable for services that are locally relevant and can help build support for conservation and sustainable management. While community monitoring offers many benefits, it also faces challenges. Data quality can be affected by local power dynamics or lack of validation. Ensuring accuracy and consistency requires training, clear protocols, and sometimes external support. Despite these challenges, community monitoring remains a powerful tool for local ecosystem management. Numerical models are increasingly used to predict how ecosystem services will change over time and space. These models help decision-makers explore different scenarios, assess trade-offs, and plan for the future. Models range from simple tools to complex platforms that integrate biophysical, economic, and social data. Several modeling platforms are widely used for ecosystem service assessment. Invest helps evaluate natural resource management options. LPJML simulates vegetation and hydrology at global scales. Aries uses artificial intelligence to model supply, demand, and flow. Other tools like ESDA, MIMES, Co-Ting Nature, and Waterworld offer specialized features for different services and contexts. Models offer powerful ways to analyze ecosystem services, but they also have limitations. Some require specialized skills and high-quality data which may not be available everywhere. Models often make assumptions that may not fit all contexts, and their results can be uncertain. It's important to use models alongside other data sources and to validate their outputs whenever possible. No single data source can capture all aspects of ecosystem services. Combining national statistics, remote sensing, field assessments, community monitoring, and models provides a more complete and accurate understanding. This integrated approach helps address data gaps and supports better decision-making at all levels. Significant progress has been made in monitoring ecosystem services, especially for provisioning services like crops and water. However, gaps remain, particularly for regulating and cultural services and for measuring contributions to well-being and value. Improving data coverage and consistency is an ongoing challenge for researchers and policymakers. Crop production is one of the most commonly measured ecosystem services. National statistics track total production, market value, and trade. However, these numbers often miss subsistence farming and do not account for the ecosystem processes, like pollination and soil fertility, that support crop yields. Integrating ecological and economic data provides a fuller picture of crop services. Water services include both the supply of clean water and the regulation of water quality and quantity. National databases and remote sensing provide information on water availability and use, but often lack detail on water quality or local access. Field assessments and community monitoring can fill these gaps, especially in regions where water is scarce or contested. Climate regulation services such as carbon storage and greenhouse gas uptake are monitored using a mix of remote sensing, field measurements, and models. International standards guide the measurement of carbon stocks, but data availability varies by country. Accurate monitoring is essential for climate policy and carbon markets. Cultural services, such as recreation and aesthetic enjoyment, are harder to measure. Data may come from tourism statistics, surveys, or local assessments. These services are deeply valued but often overlooked in policy and economic analysis. New methods are being developed to better capture their importance. Managing ecosystem services often involves trade-offs. For example, expanding agriculture may increase food production but reduce water quality or biodiversity. On the other hand, some actions can create synergies, such as restoring wetlands that improve both water quality and flood protection. Understanding these relationships is key to sustainable management. Scenario planning uses models and data to explore how ecosystem services might change under different future conditions. This helps policymakers and communities prepare for challenges like climate change, population growth, or new technologies. Scenario planning supports proactive, rather than reactive, decision-making. Including stakeholders such as local communities, businesses, and policymakers in monitoring and decision-making ensures that ecosystem services are managed in ways that reflect diverse values and needs. Stakeholder involvement increases the relevance and acceptance of management actions and helps balance competing interests. Creating networks for monitoring ecosystem services allows for sharing data, methods, and best practices across regions and countries. These networks help standardize approaches, fill data gaps, and build capacity for effective monitoring and management. Collaboration is essential for tackling global challenges. Monitoring ecosystem services provides the information needed for sound policy and decision-making. By understanding the status and trends of services, governments and organizations can set targets, track progress, and adjust strategies to protect both people and nature. Informed decisions lead to more sustainable and equitable outcomes. Despite advances, challenges remain in monitoring ecosystem services. Data can be patchy, inconsistent, or outdated. Some services, especially cultural and regulating ones, are hard to quantify. Improving data quality, coverage, and integration is a priority for researchers and policymakers worldwide. New technologies and methods are improving our ability to monitor ecosystem services. Advances in remote sensing, data analytics, and citizen science are making data collection faster, cheaper, and more accurate. These innovations are helping close data gaps and support better management decisions. Many governments are now integrating ecosystem services into national accounts and policy targets. This shift recognizes the vital role of nature in supporting economies and societies. By valuing ecosystem services, policies can better balance development and conservation goals. International agreements like the Convention on Biological Diversity and the Sustainable Development Goals highlight the importance of ecosystem services. These frameworks set targets for protecting and restoring services and encourage countries to monitor and report on their progress. Ongoing scientific research is essential for improving our understanding of ecosystem services. Researchers develop new methods, collect data, and test models to provide the evidence needed for effective management. Collaboration between scientists, policymakers, and communities is key to success. Protecting and enhancing ecosystem services is central to achieving sustainability. By understanding and valuing the benefits nature provides, we can make choices that support both human well-being and the health of the planet. Sustainable management of ecosystem services is a shared responsibility for all. Ecosystem services are the foundation of human well-being and economic prosperity. Monitoring and managing these services requires a mix of data sources, methods, and stakeholder involvement. By valuing and protecting ecosystem services, we can build a more sustainable and equitable future for all. As we move forward, continued innovation, collaboration, and commitment are needed to improve ecosystem service monitoring and management. By working together, we can ensure that nature's benefits are available for generations to come. Let's keep unlocking the value of nature and making informed choices for a better world.